The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. I wanted to thank you all for joining us today for our webinar, Analytics in the Cloud. Before we get started, I just wanted to mention again that you've joined the webinar today muted, and that you can listen in using your computer speakers or your telephone. Again, if you just click the audio button on the little GoToMeeting panel, you'll see those two options right there. During the presentation, again, we're going to invite you to write your questions in. Again, on your right little panel, there's going to be a little question drop, and you can type your questions in there, and we're going to be going through those in order at the end of the webinar today. Now with that, I'd like to get started by introducing our speaker today, who's Deepak Singh, who's a Senior Business Development Manager at Amazon Web Services, and he's really going to be diving into the details about doing analytics on Amazon Web Services Cloud.
Hello, everybody. Thank you, Reed, for asking me to do this webinar. I'm quite excited to talk to you today about various ways that our customers can and are doing all kinds of analytics using Amazon Web Services. Given the breadth of this topic, given the number of customers doing interesting things, there is by no means that I can do justice to the field, but and I'm sure I'll miss out a lot of potential examples and opportunities. So if you have any questions, or about certain things that I might not have covered, please do ask through the chat window, and hopefully we'll be able to get to them. So once again, welcome everybody, and this talk will probably last another 30 to 35 minutes, maybe a little longer, so there should be time for questions at the end. Quick background about myself. I'm responsible for business development for our compute services, which includes Amazon EC2, Elastic MapReduce, Amazon Elastic Beanstalk, and other compute services. But I also have a background in molecular modeling and large-scale genomic data analysis and bioinformatics. The reality in which we live in today, and this is, some would argue that this has been a reality for a long time, but the scale and the order of magnitude sort of keeps going up, is that we have to deal with lots of data. We cannot avoid it. Any business you are in, any task that you're doing, data is a critical path in being successful, and we just have to deal with it. This data can come from any kind of source. There's just some of them mentioned here. If you're in astronomy, you're mapping the universe, galaxies. If you're doing genome sequencing, you're sequencing DNA and producing terabytes of data. Any small one-person web startup is producing a lot of logs. Your operating system, your infrastructure, all of that is producing some kind of logging, which can be analyzed and harnessed. There's Clickstream data, which is critical in the advertising and modern web industry. Banks and security companies collect data to be able to detect signals and fraud. You have all kinds of sensor equipment. If anybody reads a lot of, for example, at the Strata conference next week, or if you read Technology Review, you'll always hear about sensors and near-field communications and RFIDs and sensors in the oceans collecting information. All of these produce data. And of course, there's things like geolocation, map data. All of this is collected again. This is just a snapshot of the various kinds of data that we have to face, and we are collecting, and we have to figure out what to do with. So our goal is to try and harness this data and try and figure out what are the kinds of information that we can get from all the data that we're collecting, all the data that we can access from public data sets, government information, all kinds of other information that's available to us today. At any company, you want to gain better business insights. This could be, okay, what product should I recommend to somebody having known their purchasing patterns, or what some friends of theirs in a more social world might have purchased, or what kind of movies you might watch. This is more on the consumer side. On the enterprise side, you want to gain business insights into product delivery, product shipment schedules, product direction, maybe even the direction of your company. And in the end, you want to make better decisions. These could be for, consumer retail company, an enterprise, a researcher trying to figure out what what's the next experiment that they should be developing. In the end, if we can harness the data that we have effectively, we can be more successful. This allows us new business opportunities, new product opportunities. I don't talk about scientific advances, but that too. But regardless of all of this, the people in these companies are the ones who are driving the innovation. The people are the ones who are the data scientists, the algorithm developers, the people with the massive stack knowledge, machine learners, who can take all this data, combine it to do interesting things, and derive useful insights. But these people face challenges. They want to live in a world where they can go from an idea to a successful product. But too often, you end up running into brick walls. That's my poor representation of a brick wall there. And when you run into a brick wall, your chances of developing a successful product, gaining useful insights that help you do valuable A/B testing, put products on shelves, find the next scientific discovery, they either get slowed down or you can't reach or you can't get there. And these barriers can be of all kinds. In a data-intensive world, these could be just sheer data volume. They could be the structure of your data. Very often, especially these days, you have semi-structured data of all kinds, which you have to try and harness. This data is often multidimensional, and you have to try and figure out what you can do with it. But there's other kinds of barriers that you face. Resource constraints. You just might not have enough storage and compute infrastructure, especially, or you might just buy a lot of disk and then not know what to do with it once it's all in place, or you're having to deal with disk failures and all the challenges that you get when you're at scale. Budgets are always tight. Even in good economies, you can't just randomly throw money at things. So you have to think through how you're spending your money on resources, on people. And you spend a lot of your time doing what we like to call undifferentiated heavy lifting, the muck that's required to be successful in any field. We want to get rid of this. The problems with data volumes, the problems with data structures, the problem with data dimensionality are not going away. That's why we hire smart people to try and solve those problems. But these are the problems that they don't want to deal with. And we believe that the cloud, specifically Amazon Web Services, is a very useful tool for anyone who wants to take data and harness it for more insight. So what is Amazon Web Services? I like to describe Amazon Web Services as a set of infrastructure services, a set of building blocks that you can use to build stuff. The stuff could be gaining insight from data. It could be a web application. It could be just a toy application that your child develops in school to try and see, just try and learn programming. Once you have the necessary low-level blocks, you can do a lot of interesting things. And our set of building blocks keeps increasing. I have to take a new screenshot every week because we release something new. If we divide them into the following categories, the ones that will be of most relevance today will be our compute category. That includes the Elastic Compute Cloud, Amazon Elastic MapReduce. We have storage and database solutions ranging from single-column data store, NoSQL data stores like SimpleDB, to manage MySQL services, to a vast variety of storage solutions, including Amazon Simple Storage Service and the Amazon Elastic Block Store. And I'll talk about these a little bit more in a few slides. I won't go into detail on the services today. There's a lot of information on our website which you can gather, and we are always happy to answer follow-up questions or if you have any clarification questions today. We also started providing services like Amazon Elastic Beanstalk, which makes it much easier for you to deploy Java web applications, for example. Provides you an Apache Tomcat container that you can deploy WAR files to. And this is one of the new services that makes me take new screenshots all the time. Some of the core features of Amazon Web Services, any service that we developed, is that it should abstract out the underlying resources to the end user. So when you're provisioning servers, you're not racking and stacking them, you're talking to them through APIs. When you're provisioning storage, you're spinning up block devices just using APIs or interfaces that leverage these APIs. Once you have APIs, you have very programmable infrastructure. You can program it using third-party libraries. There's all kinds of possibilities that happen when your infrastructure becomes a programmable asset, becomes an object that you can talk to through a machine. All these services should meet and have to meet a certain security bar. And then the more common aspects of AWS that people tend to think about. They need to be on demand. They need to be pay as you go. So you should only pay for them if you're using them and while you're using them and for what you're using. And they have to be elastic. You need to be able to increase the amount of resources that you're using and reduce the amount of resources that you're using based on your needs. And elasticity, actually a combination of elasticity and pay as you go and on-demand nature, prevents you from landing up in situations where you are trying to predict ahead, you're buying infrastructure, or you're putting in resources and you find you're either too short or too high. When you can track your resource consumption, you become much more effective and efficient at how you use those resources. So you don't end up with wasted resources, and you don't end up with customer dissatisfaction or opportunity costs from predicting when your actual usage goes up too high. And that's what allows something like a hedge fund to use the Amazon Elastic Compute Cloud, EC2, in this way, where they spin up thousands of nodes every night for several hours and spin them down in the morning when the markets are open and they're trading. And then again at night, they start doing modeling and simulations, trying and doing new pricing models or whatever hedge funds do. This is a structured products company that does that. And on weekends, when they're not using these, when they have limited use, they go back down to a more common baseline. This kind of usage pattern is especially important in analytics, where very often you'll have a predictable use where you're using some sort of resources for a period of time, and then you have ad hoc needs when you have like a big billing run coming, or you have a certain brand new product that you want to try and figure out, or you have some other insights that you need to develop. So what are the requirements for anyone doing analytics? And the requirements I'll go through are relatively simple, but they are the baseline requirements that you have to have if you're going to be successful. You need scalable storage. As you collect more and more data, you need to put it somewhere. And you need different types of storage because there is no one-size-fits-all solution. Because you have structured data, you have unstructured data, and you're collecting it from multiple places. You might be ingesting data from public resources to enhance the quality of your data or to match it up. You need scalable computing resources. You've already seen a really good example of the kind of scalable computing resource and the advantage you get when you have access to data and different varying needs. These resources need to be available on demand. You might not need them all the time, or you might need some subsection of them all the time or often, and then for burst you might need more. The same goes for storage. Sometimes you suddenly get, you have your marketing company and you run a campaign, and it's way more successful than you had ever imagined, and you have to be able to handle that and scale up to those needs very rapidly. And Amazon provides these to you. I have earlier spoken about a simple storage service, which is a massively distributed object store, which is designed for 11 nines of data durability. So your data is highly available and highly durable. It can handle multiple facility failures. And every object that you put in Amazon S3 is addressable. And Amazon S3, because it's a great store of record, often forms the baseline of a lot of our data sets that people use to do analytics. Whether it's people storing geolocation data, image data, log data, pricing data from exchanges, they can take this data, stream it in to Amazon EC2 or Amazon Elastic MapReduce or some other analytics engine, do what they need to do, maybe push it into a relational database afterwards for offline querying. It's a great data store that scales essentially to infinity. Depending on your access patterns and your access, IOPS needs, it may not be the right option, but for a lot of cases where you're streaming in data, it is, because it can horizontally scale as much as you want to. It's a very viable and popular solution. The Amazon Elastic Block Store is persistent attached storage. It's a block device that you can provision and then up to a terabyte, but you can provision multiple devices, put a file system on them, put databases on them, strike them, and attach them to Amazon Elastic Compute Cloud or EC2 nodes, which of course is our Elastic Computing workhorse and probably the AWS product many of you and most of you are familiar with if you've used AWS in the past for your analytics needs. You might also need some form of database. The analytics cases that we see, a lot of enterprises use various kinds of relational data warehousing or databases to query their data, to do analytics, to publish reports. At Amazon, we provide Amazon a relational database service, Amazon RDS, which is a managed MySQL database, which has various, apart from the fact they don't need to be your DBA needs get lowered because we are taking over that for you. You have the ability to quickly scale up. You want to go from one database size to the next one. That's an API call away. If you're using multi-AZ RDS, you can fail over into another what we call an availability zone. If you have any issues with one particular one, you can automatically scale read replicas if you have read-heavy workloads. So there's a lot of automation and capabilities provided by RDS, and we'll continue to enhance the service as more and more people use it in more and more interesting ways. But you can also run the database of your choice. Amazon EC2 and EBS give you a blank slate to work on, to run all kinds of databases. I neglected to mention that we also provide SQL Server as part of the core EC2 offering. Oracle, for example, certifies, supports, and licenses most of its product line on Amazon Web Services now. This includes the Oracle databases and various enterprise business solutions. And a number of people are using Oracle as a data warehousing analytics solution on EC2 today. I pointed the example of Recombinant Systems, which developed a biomarker warehouse for a big pharmaceutical company that allows, and it's a global company, this is a centralized warehouse, which allows researchers to start pulling in information about publications, about clinical trial data, about preclinical data, to try and make decisions on what's the next drug that they need to work on, or the state of a project, and report on this. And these are just some numbers from a few years ago about some of the cost advantages that they face. We've since dropped prices, so this predates at least one price drop, maybe even two. You can increasingly, customers are using highly scalable share-nothing MPP style systems. Vertica is an excellent example of that. You can run the Vertica Analytic database on Amazon Web Services. There's a number of retail companies, a number of consumer web companies and enterprises using Vertica and its scalability on AWS. And in fact, with the recent release of a cluster compute instance, which provides you very high quality, high bandwidth, low latency networking, we've seen the adoption of some of these database types even go up because you can have very high scale and large, highly performant databases running on the Amazon cloud. Another example of a share-nothing database that is popular with our customers is the Aster Data N-Cluster Cloud Edition. There's companies, I believe companies like ShareThis, that are running Aster Data on AWS today, and other companies in a very similar mode to Vertica. And there's other companies in this space, I'm not going to mention all of them, that are providing high-performance database systems or data warehousing systems on AWS for analytics, to companies of all sizes. You need reporting and business intelligence tools, and you can start off by going, for example, RightScale provides you a package solution for somebody BI needs, where it combines Talent, Vertica, and Jaspersoft into a single package that customers can acquire and do BI on AWS without having to pick and choose different solutions and match them up themselves. You can run something like SAP Business Objects. What you are seeing on screen is the architecture for recovery.gov, which is a federal website that runs on AWS. It runs on top. It takes advantage of a number of solutions out there. The one I wanted to point to is SAP Business Objects, which is their which is their BI layer, which allows them to use tools that they're familiar with, that they know. And as you can see, almost everything that you see on this chart is something that you are likely to have used in some capacity before or might be interested in, but you can run on the AWS side. But as data has evolved, as the volumes of data that we collect and the types of businesses that we run change in the world of the web, you have new paradigms for data analysis. And one of those challenges that we face is just the sheer volume, the sheer rapidity, and the sheer diversity in the kinds of data that you're collecting. So what you end up needing is unconstrained tools for unconstrained growth. In fact, I would strongly encourage, I'll throw a shout out to a chapter in a book called Beautiful Data, written by Jeff Hammerbacher, on how Facebook developed the data platform. It tells you a lot about the kinds of challenges a company like that faces in this world, to think through some of what people need to, what companies growing rapidly in the web have to face. And our solution for that is Amazon Elastic MapReduce. What is Amazon Elastic MapReduce? It's a workflow engine. It's a job flow engine. It's a managed Hadoop system. It's many things. At its core, what it allows you to do as a developer, as an analyst, as a business intelligence person, is to be able to point your application, which somebody's written, a MapReduce application, in its simplest form, to a data source, and click go. We take care of managing your Hadoop cluster. We take care of making sure that things work well. We provide you debugging tools and logging tools and make sure that the data ends up where you want it to. And we've been working on developing an ecosystem that allows you to do this more and more easily. And over the next several minutes, that's what I would like to talk about. So as I said, Elastic MapReduce is built on Hadoop. What Hadoop provides you, Hadoop is a system that allows you to do very, very distributed analytics, distributed data processing on very large data sets on commodity hardware. And that's the core design choice. It distributes data and makes data locally available to compute to the mappers and the reducers to do effective data processing. It has two components, loosely speaking. One is a distributed file system, HDFS, again, designed for commodity disks. And the other, of course, is the rather well-known MapReduce paradigm that was originally published by Google, which allows you, which provides a simple, elegant programming model to harness very large data sets effectively. It's not applicable to every situation, but for a lot of semi-structured data, it works really, really nicely. And we've seen people adopt it in greater and greater numbers over the last several years. The goals for Amazon with Elastic MapReduce are to handle the undifferentiated heavy lifting. As I mentioned earlier, that's the kind of blocker that your analyst doesn't really want to deal with. They just want to do the analysis. They want to develop new algorithms, gain new insights. They don't want to deal with cluster management, trying to figure out why, how they want to store their data, etc. Elastic MapReduce is tightly integrated with all of other Amazon cloud services, a big chunk of them, and we plan to improve this integration over time. For example, it uses Amazon S3 as its core data store, but it also can send data into RDS, into SimpleDB, into Vertica, for example. That doesn't matter. And in the end, it is Hadoop. You can use the same Hadoop code that you use in other places. Your code is transferable. You can, if you're running a small cluster internally and a large cluster on Amazon for production, you can. It's the same code because it's just Hadoop. And because it's just Hadoop, it also supports a large chunk of the Hadoop ecosystem. For example, one of the most common ways of accessing Elastic MapReduce actually is not native Java MapReduce, but actually using Hive, which is a SQL-like language developed at Facebook for the analysts to do data warehousing kind of work. People at Yahoo have developed exactly graph-style scripting language called Pig for similar reasons. It's a high-level language that allows you to express what you want to do without having to go into the functional programming paradigms of MapReduce. And something that's not part of the core Hadoop project is a workflow system, data flow system called cascading, which is, again, really popular with a lot of people because of the way it allows you to express your data and not have to worry about writing MapReduce functions. And we see these kinds of paradigms becoming increasingly popular. In fact, we've seen people build other systems on top of MapReduce, which integrate into Elastic MapReduce, where they can work in, for example, in their native Ruby libraries or in Python and so on. And what are customers using Elastic MapReduce for today? A variety of workloads, targeted advertising, especially Clickstream analysis, one of the most common use cases that we have. Data warehousing is getting more and more popular. People are doing bioinformatics, financial modeling. Just processing files, I think one of the most popular Hadoop examples out there now, and which is kind of dated, is the New York Times converting a large number of PDFs into TIFF or TIFFs into PDFs to create their Times, for the Times of New York Times archive on EC2 several years ago. So still a very common workload pattern with Elastic MapReduce, web indexing, and in the end, just machine learning, data mining, business intelligence kind of work. A lot of increasingly used for graph type applications as well. And there's a lot of chatter on the web And if you're at Strata next week, you'll probably hear a lot about this, or any of the core Hadoop conferences that are popping up all over the world. An example of clickstream analysis is Razorfish, which is now part of Vivacy. Some rather well-known retail company came to Razorfish once. They had about 3.5 billion records, over 70 million unique cookies, over 1.5 million target ads required per day. And they wanted to do a better job of targeting these ads. A common example, this toy example here is this is something that I did this year, purchased a home theater system sometime around Christmas. I wasn't looking for video games, but if I had, and they had figured out my buying patterns based on this analysis, they'd probably be able to serve me a recommendation for buying Madden, which I might have bought if I was interested in that. And the way they solved this problem was they ended up using AWS and Elastic MapReduce because their existing infrastructure was not designed for something of that scale and that rapidity. They would have had to provision their infrastructure, purchase it. And they purchased what they ended up doing was using a 100-node Elastic MapReduce cluster on demand. I believe they used cascading when they did this. The processing time that they had went from 2+ days on what they had before to 8 hours. And basically, the ad spending, the return on the advertising spending went up by about 500%. It's just one example of what people do with clickstream analysis. And here's a quick picture of a typical, not too uncommon example of what a clickstream analysis architecture might look like, where you have some kind of data flow manager that's collecting data from log files, from relational databases, from various APIs. It's a holistic view of data systems. It's trying to build a data platform for this unconstrained growth that I talked about earlier. You have many, many sources of data, different types of data structures. You pull them all in, and then you start running Hadoop, which doesn't really care. At the end of it, Hadoop's almost like a great ETL system. You can put it into a key value store or some kind of store like HBase or SimpleDB. You can use ODBC drivers to pull it into an OLAP cube, and then serve this out through a web application or presentation layer to your internal people, if you're doing recommendation engines on a consumer website, or you can just continue doing direct analytics processing using further MapReduce workflows. So this was almost a rinse and repeat use case because we see it all the time from companies of all kinds, collecting all kinds of click information. You can swap out different pieces with your favorite data warehouse of choice, with something like a Vertica, but all doable and increasingly done. Another example is Etsy. I'm sure most of you know what Etsy is. This is Etsy in October of 2010. They had almost 0.5 terabyte of web blogs in October, hundreds of millions of page views, millions of total favorite listings. It's an arts community in the end. And this is Etsy's architecture for doing using Elastic MapReduce, where they're collecting data from Etsy.com, from their edge network, taking all these log data from their distribution logs, putting them into Amazon S3, doing Elastic MapReduce work. They report that using a notification service, and they might throw data into spreadsheets, put it back into Amazon S3 for further work. Again, simple, elegant, easy to do. And again, done by a number of people working with logs, for example. And this is just the code that does it. And actually, there's many examples that you'll find on the web. All you have to do is, if you Google for Elastic MapReduce and log analysis, you'll find many, many examples of what people are doing. What we've also seen increasingly is people doing classic data warehousing, something like Vertica or an Oracle-based warehouse or something like that, or increasingly going all HDFS and using something like Hive to do all the data warehousing. This is an example of web-scale data warehousing, just a common cartoon of a workflow. Your data starts off in Amazon S3. You have extreme parallelism over data subsets because we've got great Hive integration, and we actually spend a lot of time trying to make Hive work really, really well with Elastic MapReduce. Hive provides you SQL-like manipulation too, so if you're an analyst used to SQL, it's not that different from what you've done before. And if somebody can set all of this up for you, you're still pretty much in SQL-like land. Then you can then throw this data into something like MicroStrategy, traditional BI tools. You can do more processing You can do ad hoc querying, the kinds of things you would do with a data warehousing system. Here's an example of what what an architecture might look like. Once again, you're collecting data from databases, from log files, from Clickstream data. You're bundling, putting all of this in S3. You're throwing all of that in. You're spinning up Elastic MapReduce clusters. Some of it might be sustained long-term analysis, which they're always doing something. You could add resources to them, and you could spin up new clusters. And we've actually developed features to help you do this more easily that I'll talk about in a second. And then at the end of it, you can throw into an OLAP cube, do something like MicroStrategy, or you could push it towards something like Astrodata Vertica and do your reporting there. Or you could just stay in that second tier that I've talked about, and there's many options that you have available to you, and ODBC and JDBC type drivers as well, so you can just write SQL. So as it says here, there's a SQL-like access at every tier in some form or the other. I mentioned the fact that you can, we are developing tools to help you scale and do ad hoc processing. One of the features that we released last year was the ability to resize running job flows, where you have a job running, you want to do it faster because your boss wants this, if anybody's seen Office Space, they want their, what's that, TP report or whatever that they keep
TPS report.
TPS report, you expand your cluster, get it down to 7 hours, he comes back, okay, you just expand it further. You don't need to restart your job. You don't need to start from scratch. You don't need to stop in the middle and checkpoint. You can just expand your cluster, get your work done faster. These are the kinds of things that we are trying to spend our effort on to do. Another example is what we call agile data warehousing, is that you have a steady state for your warehouse, which is doing analytics all the month, all the time. And then you have a reporting run come at the beginning of a month or end of a quarter, where you just need more resources. You can, again, leverage this flexibility of being able to resize your cluster, and then, when required, go back to your steady state. And that's, again, a very common pattern and a very common request that came a lot, which is why we developed this. One thing we've announced that I don't have slides for, and we haven't shipped yet, but hope to do so soon, is support for doing this with Spot instances. And for those of you who don't know, a Spot instance is an EC2 instance where you can bid, you essentially submit a request saying, this is the price I'm willing to pay. And if the market price below that is below the price you request, you get your instances at a much lower price, at whatever the market price is, the spot price. So the functionality that I've talked about in the future will actually be enhanced by the ability to do these ad hoc or sudden burst runs, if available, with resources at a much lower cost. I should have put slides in for that, but I didn't because it's actually not shipped functionality yet, but something we've announced that we're working on. Again, this is analytics and BI, and not a space that's new. It's the scale and the paradigms that are evolving. But our goal is also to try and develop a very rich ecosystem around Elastic MapReduce. So we've spent time with, we've added support for MicroStrategy and Pentaho, analytic solutions like DataMirror, which is a spreadsheet-like solutions, and KarmaSphere, which is an integrated IDE that allows you to run mix and match Hadoop with other things, and Elastic MapReduce with other tools, and do very interesting things, things like beeswax in the open source community. And we're interested in, if you have some solution that you feel would benefit from being in this ecosystem, we're interested in talking to you, or something that you feel is missing and somebody we should be talking to. We are always open to ideas. Some practical considerations, things you need to think about as you head in this direction. AWS Web Services Management Console, which is the simplest way of using this. You literally point, in the most simple way, you put to the bucket where the data is in S3. You point to the bucket or the address where your code lies, and where you want your data output, and you hit to the size of your cluster and you hit go. That's it. More advanced functionality comes if you go into the Ruby command line interface or start leveraging the REST API. There's actually a number of third-party libraries that take advantage of the fact that this is, like all other AWS resources, programmable. For example, Yelp has developed this really nice tool called Mr. Job, which is a Python-based application that does it. There's people who have chef recipes that manage Elastic MapReduce clusters. There's all kinds of tools. I believe there's a Ruby library called Wukong from the InfoChimps, which has early Elastic MapReduce support as well for people who like programming in Ruby. You have to think about what kind of hardware that you're using. Amazon Elastic Compute Cloud provides, EC2 provides you a number of instance types, where an instance type is a mix of CPU, RAM, and local disk designed for different types of access patterns and different kinds of usages. And depending on the kind of job you're running, you need to choose your instance type carefully. And here's some recommendations we have. If you have data or I/O intensive, if you have just M1 and M2 instances, very common for data mining for Clickstream, logs, even for data warehouses. And the more I/O intensive you get, and if you just need brute force computing power, our C1, which is a high compute instance, or our CC1, which is our relatively newly released cluster compute instance with very high bandwidth, low latency networking, become very popular. And we are seeing increasing use of Elastic MapReduce with cluster compute instances for people who, for example, might be shuffling terabytes of data during the shuffle phase of Hadoop. Just some practical considerations that we've learned from what people have been doing. There are no hard and fast rules as such, and we encourage you to try things out and find the instance type that's optimal for you. Some additional resources that I would encourage you to go to. The first place is our Elastic MapReduce detail page, which is at that URL below. There's also a number of articles and tutorials that you can get to from that page, done by our team or by people in our, by developers that use Elastic MapReduce. The most recent one, and one you can have fun with and enjoy and get to know Hive also very quickly, is a tutorial that uses the recently published Ngram data that Google published from books from the last God knows how many years, that you can then, there's just a simple step-by-step tutorial that allows you to run various queries against it. And we've made the data available for you, so you don't have to load it up. We also have on our YouTube channel a number of videos on how to use things like Hive and Pig with Amazon Elastic MapReduce. Again, these are screencasts done by our engineering team. Again, encourage you to check those out as well. So, in summary, Amazon Web Services provides you a set of resources that fulfill a certain set of criteria. They're on demand, they're pay-as-you-go, they're elastic. You have abstracted programmable resources that live in a very secure environment. Provides you many database options depending on the nature of your analytics needs. And of course, I spent quite a bit of time talking about Elastic MapReduce, which is our managed Hadoop solution for very, very distributed, very large data analysis on semi-structured and sort of holistic data analysis on semi-structured and structured data. The core is that depending on your use case, depending on your choices, you have powerful, flexible, elastic analytics capabilities and data warehousing capabilities. And what we are trying to do is take you from being blocked because of things like the muck by resource contention and helping you develop successful products. And that might be your fortune. The more unblocked you are, the more unconstrained you are, the more interesting things you can do, and it becomes a question of priorities and finding the right smart people to do those things. And with that, if you happen to be at Strata next week, Amazon Web Services will be there. Our CTO, Werner Vogels, is giving one of the keynotes, and I believe Jinesh Warrior, who is one of our evangelists, is doing a panel. And there'll be other people at the Amazon booth that you can talk to about your analytics and big data needs at the conference in Santa Clara. And with that, I end my talk. Here's my contact information, and I'm happy to take any questions right now.
Great. Well, thanks so much, Deepak. Again, please keep the questions coming in. We've already had a good number, and we have some great questions. Typically, we just take them in order, but I already see some grouping themes starting. But just one question for those who are sort of newer or considering analytics in the cloud for the first time. What might be a great trial use case, or some way they could just experiment with analytics in the cloud that gets them, just gets them started, so they can say, hey, is this for me or is this not for me?
Yeah, and that's one reason I put the articles and tutorials page up. Some of them are a lot of fun. We have, depending on which industry you come from, I think the n-gram data is very generic to any kind of text and pattern analysis. So if that's the kind of thing you want to do, that's a great tutorial to do. We have examples for log analysis and more comparative, if you come from like a consumer web company. Those are the places that I would start, try and get a sense of how these tools work and proceed from there. I think what you'll start seeing in the future is people developing things using Elastic Beanstalk, where they might make a Java web application available that they can just run and deploy. I think that will be the way to do it in the future. But right now, I would definitely encourage people to try out these tutorials. If you come from a more relational backend, some of these companies, like Astrodata and Vertica might provide you, I'm not 100% sure, but might provide you a demo version of their application to try it out. In the end, the best way to learn is actually try AWS out. You don't have to be an expert necessarily, because you can have access to third-party tools. You have access to consoles that try and reduce the barrier. And if you are familiar with a toolkit like Talend, Jaspersoft, and Vertica, I would strongly encourage you to go to talk to somebody like RightScale and use their integrated sort of package solution to do that.
Roughly, doing one of those tutorials, what's actually that going to cost a company to do?
Yeah, so something like the Hive tutorial, where we've kept the data, for n-grams, where we have the where it's step-by-step, where we have the data available, so you don't need to even jump in, or it's going to cost you a few dollars and a few hours, because chances are you might make some mistakes if you have never used AWS before. And for like $10, $20 and 4, 5, or 6 hours, you'll learn a lot. Those are that's kind of how I learned many years ago.
That's great. Well, we definitely have a theme in the questions coming around data, due to the fact that a lot of the analytics use cases are using a large amount of data. It's about, what are the best practices for bringing data in?
Yeah.
And then related to that are, in terms of, we'll say, economies, bandwidth costs in, bandwidth costs out.
Yeah.
And the reason I'm asking those together is, I think there's some best practices we can share that will actually help on the economies of dealing with the large data sets.
Absolutely. So I'll answer this in multiple dimensions. There are public data sets that we are trying to accumulate inside Amazon, so that you don't have to bring them in all the time if you need them. This could be census data, this could be scientific data, this could be things like the n-grams data, which you can just leverage because it's already inside Amazon. See, that's one part of it, and we'll continue doing more and more. There are companies that are providing their data sets inside AWS because they know there's a lot of users there. So that's the second, and we would like to talk to all of these companies and other, like financial service providers about getting this data in. But there are a set of best practices that you can use if you are bringing data in and out. Part of it is you have to think through, do you really need to take the data out, or can you keep it in and only pull out slices? Because in the end, the internet is your biggest bottleneck. Physics is reality. For people who have occasional jobs where they have a big data dump coming in once and maybe a dump going out, we provide actually a service called Amazon Import Export, which is actually a physically shipped disk into AWS. The dimensions that we charge you on are the number of devices you send us. So these days, with devices getting bigger and bigger, if you have a few, 2 or 3 terabytes of data, you can actually send us just one disk, and that's all you'll be charged for is one device. And the time it takes for us to take the data off and put it into S3, we give you a full log and audit of that. It's relatively inexpensive. It's very high bandwidth. The latency is a couple of days, but you'll get your data in pretty effectively and relatively inexpensively. If you have terabytes and terabytes of data, and you're doing it on a regular basis, I would suggest you come and talk to us. There are things that we can talk to about what are the most effective ways over the public internet, or if there's any other arrangement that we can come to on getting the data in. I would strongly encourage you to reach out to AWS, because there are best practices that we can share depending on your connectivity, depending on the volume of data that you're moving, and the kind of data. But definitely, we find that the import-export service has been huge for people who have like periodic data dumps that they need to do. For web companies that are always sending data, their incremental data volume is actually not that large, so they can come in over the public internet. We have best practices around how to get data into S3 using things like window scaling, parallel uploads. The new S3 feature around large objects and multi-part uploads makes things very, very easy, because you can split your payloads up into multiple small parts, and we collect them all at the end. So there are a number of things, and we continue to investigate how we can lower the barrier. Yeah, and our cost model is on storage and transfer is tiered. So the more you put in, the cheaper it gets. But you asked to reach out to us, and we should have a discussion around that.
Great. Well, thanks, Deepak. We're going to go to the next question. It's actually the first question asked by Sachin. This is, do we support Oracle RAC currently?
No, we do not support Oracle RAC right now. There are technical and some limitations around the RAC requirements. We continue to try and figure out what are the best ways to do it. It's a request we've heard from customers. I think some of the advances that we made with cluster computing last year put us on a potential path. Don't have any dates, timelines, promises. I can't commit to anything, but definitely something we're investigating and would like to be able to support because it does come up from a lot of customers.
Okay, Naveen asked, does AWS offer differentiated hardware platforms such as with GPGPUs?
Yeah, so we provide, I would describe our EC2 platform into two categories. One is what I like to call the classic EC2 platform, where we provide a number of instance types where we abstract away what's the hardware underneath. We tell you roughly what the CPU power, number of cores, and the expected performance from the CPU. You know what RAM you have, but you don't know what kind of processor you're running on. It's commodity generic hardware, and I/O is a shared commodity. Last year, we released a new platform, what we call a cluster platform. In the cluster platform, we tell you what hardware you're running on. For example, it's currently based on Nehalem Xeon 5570, the highest 2.93 gigahertz frequency that you can get. 8 cores, hyper-threaded. You know it's on what kind of memory it has, very fast DDR3 memory. And we extended that, and it all sits on a 10 gigabit Ethernet network where using the concept of a placement group, you can get full bisection bandwidth between all nodes inside a placement group. So very high performance clusters, it was in the top 500 supercomputers in the world. We added a second instance type to that in late November, I think, called the cluster GPU instance, which is the same hardware platform. But in addition to the 8 Xeon cores, you now have 2 Tesla M2050 graphics cards for CUDA OpenGL type workloads. And in fact, financial modeling is one of the more common use cases we've seen. There's a lot of people doing Monte Carlo analysis in the financial world, doing insurance kind of stuff.
Great. Well, Naveen has our next question and asks, does AWS offer hardware optimized to process specific data types, such as video or images?
No, we do not provide hardware, specialized hardware. Our goal is, the way we think about it is what kind of demand can we generate from a commodity platform, because we can scale that much more effectively. So the most specialized platform that we have out there is our GPU platform. But given the fact that it's on a commodity instance and NVIDIA GPUs are fairly commoditized themselves, that's the most specialized platform that we do provide. The kinds of hardware accelerated platforms that you might be thinking of is not something that we provide today. We're always interested in the kinds of workloads you're interested in running and the kinds of performance that you're interested in seeing, and that helps influence our decisions.
Matt asked about MongoDB on EC2.
Yeah, so MongoDB runs, there's a lot of people running MongoDB on EC2. I believe both Mongo HQ and there's another Mongo, Mongo as a service out there that run on EC2, and many of our customers are running Mongo. I think, again, there's some people running in on a cluster instances as well.
So Dino's asking a question a little bit about roadmap. Just so you know, we don't typically talk about anything that we're working on until it's available. However, also, even if we have customers that are using a specific type of software, unless we have permission from them, we don't reference them. I'll ask this case and this question, let Deepak respond. As is, though, are there any plans for being able to host SaaS products? Are customers using SaaS for analytics in EC2?
I cannot specifically speak to that. I've heard rumors that people have run SaaS on EC2. I believe there are certain licensing challenges that need to be overcome to do it at any scale. I know a lot of people running R on EC2, many people. SaaS I only heard anecdotal third-party evidence, so I don't have any direct information.
If he's interested in trying to learn more about that, should he contact SaaS?
Yeah, you should contact SaaS. They'll be able, if they do have a program, they'll be able to help you.
Great. It says, which version of Hadoop does EMR use? I thought there have been many bugs reported in previous versions.
Yeah, I think we are right now on 20.2, if I remember correctly. We don't always support the latest version until we are sure that it's stable and bug-free. I think we, for example, skipped Hadoop 19 and went straight to 20 from 18. Obviously, we'll try and keep refreshing as often as we can for our platform. As Hadoop matures, my guess is that will become less and less of an issue because the API will stabilize, and incremental updates will probably not kill your code, just give you new abilities.
Great. Jay asks, how many local diffs are supported per node?
So that I can actually answer. I'll answer in the context of the cluster nodes because they give you, because you're very explicit there, they give you two roughly 865 gigabyte hard drives on each node. So that gives you roughly 1.7 terabytes. My guess is you're asking because of storage density, and that is something that we're interested in hearing. I'll actually throw it out there is, email me if you have use cases where you're using lots of data. Because right now, if you have lots and lots of data, the best way to use Elastic MapReduce is to scale out on a large number of nodes and distribute the data across them. If you feel that's not optimal, please email me. We're actually very interested in hearing about that.
Okay, great. The next question I'll actually ask from Brian is, how is AWS leveraging, well, he actually wants to know how we're leveraging their own data analytics and metrics these days. That's actually probably something we don't typically talk about.
I cannot talk about that specifically. If you meet any Amazonians at a Hadoop conference, you might take them out for a beer.
Can you suggest visualization tools for large volumes, time series data? Which tools are easy for startup and easy to integrate?
I'll punt on this. Visualization, unfortunately, is not something I am that familiar with, the visualization tools. People are using standard MicroStrategy type tools. People are using websites like Timetric. There's other visualization systems that have been. I can get back to you on that. So if you want more information, if you can contact me offline, I'll check with our team to see what tools that they have seen people using.
Mm-hmm. A couple quick questions here. Does AWS have a reporting/analytical tool for ad hoc reporting or dashboarding?
Not ourselves. We partner with folks like MicroStrategy and third parties for that.
Just a question on, do we have a pre-installed AMI for load sharing facility?
In terms of?
Is there a pre-installed AMI with LSF on it?
Oh, with LSF, Platform's LSF.
Mm-hmm.
Talk to Platform, actually. The Platform has, I don't know if Platform's is an AWS partner. They support our cluster instances, so definitely talk to them.
This isn't necessarily specific to just analytics, but it says, can we recompile a complete kernel?
We provide you the ability using CVGrub to upload your own kernels. It's not completely, free for all, but there is the ability to upload your own kernels using our custom kernel feature that we launched sometime last year. It's kind of how FreeBSD got working recently.
JT was also wondering if there's a way to access CloudWatch analytics from an API.
Yes. In fact, there's more ways to access CloudWatch from an API. Until last night. Last night we launched our CloudWatch console, or 2 nights ago. Now you have everything in there, mm-hmm. But for a while, actually, the API was the better way of accessing CloudWatch.
Great. Well, that actually went through all the questions there today. I really want to thank everyone for coming. Really enjoyed today's presentation. I also want to thank Deepak again for performing the presentation today, and also everyone for attending. We're going to send a follow-up email with a link to the recorded presentation. As long as all went well with the recording, we'll at least send you out the slides. And on behalf of Amazon Web Services and our presenters, I want to thank you for joining us today to learn about analytics in the cloud. Thanks again.